Now that we're beginning to get a handle on inheritance, let's go back to our clock example and see how we can go about improving it. If you remember, we have a base class called clock, a subclass called alarm clock, which adds an alarm instance variable and a getter. And I said there was something about this print statement in this loop that I didn't really like. Remember, we went through each kind of, for each clock, and for each one we printed its time because every kind of clock has time. And then we checked the type, and only if we had an alarm clock did we get the alarm. The reason I didn't like this is because it made the use of our classes have to know about what kind of class we had. And one of the nice things about classes, if they're designed well, is they should really encapsulate all of their behavior. That is, each class should do everything that it knows how to do itself, and nobody else should really have to worry about it that much. All we're trying to do is print out the clock information. Why should we, the user of these clocks, have to know what kind of clock we have if we're printing them out? Why don't we instead just ask each clock to print itself out in the best way that it can, in the way that makes sense for the kind of clock that it is? And this is the key thing that I want to introduce, which is that in addition to inheritance allowing subclasses to define new behavior, inheritance also allows subclasses to modify existing behavior. And this is a key idea, and it is called overriding. Overriding means that a subtype changes the behavior of something that was defined by the parent type. And usually this works by having the parent type, the parent class, define a method, and having the subclass redefine that method or override it or replace it. Since we're talking about printing right now, let's look at a simple description string and use that to solve this problem. So let's go back to our clock and define a description string. We know how to do that, and it can, when it's a regular clock, simply return the time, which is going to be the time, right? That's what a clock does, is it just describes itself by saying what its current time is. But an alarm clock, it defines itself, how it looks when it's printed, by returning its time and its alarm. Right? Think about this. This actually makes a lot of sense. A clock defines how it gets printed by all the information it has in itself, which is its time. And an alarm clock also defines itself, how it gets printed with all the information it has, which is its time and it's an alarm. If we do this, then we can simplify our printing code. Instead of having to have all of this logic about what kind of clock we have, this gets dramatically easier. We take all of this code that I highlighted and delete it. And what we just say is for every clock, print yourself. And remember, what printing does is it calls the description string method to return a string for that particular object that you have. If we have a clock, it'll call the clock's description string method. And if we have an alarm clock, then it'll call the alarm clock's description string method. All right, cross your fingers. Let's try running this and see what happens. And look at that. It's perfect. We had two clocks which printed themselves as regular clocks, and two alarm clocks that printed themselves with alarms. I just want to point out one other thing, which is you may have noticed that PyCharm added a few new decorations, these new icons. Let's mouse over and see what they say. When this little decoration, which is on the clock class, it says it is subclassed by alarm clock. So it's giving us a little notification that even though we're defining a class and it stands on its own, we should be aware that there is a subclass that might change the behavior. So if you have one of the subclasses, it might do something different. So what about this init method? This says the init method is also overridden in alarm clock. Sure enough, because we have an init method here and an init method here. How about this str method? Well, the str method is overridden in alarm clock, and it overrides a method and object, because remember we defined clock to be a subclass of object. An object, it turns out, has its own str method. And similarly, alarm clock overrides the method in clock. So this is very useful because it reminds us what is going on, and it tells us who is overriding our behavior and which behavior we ourselves are overriding. All right, our running example of alarm clock and clock is starting to work pretty well. I've gotten rid of my biggest problem, but there still are a few ways we can improve this. Let's look at our constructors. In clock, the base class, we define a constructor which defines our instance variable time. And then in the subclass, in the child class, we define a new constructor which also defines an instance variable time. This isn't a bug, but it's not great design because we have some repeated code. Admittedly, this is a very simple single line of repeated code, self.time equals time. But this kind of thing happens all the time, and suppose instead of it being a single line of code, there actually had been a substantial amount of initialization that had happened in the base class. We certainly wouldn't want to duplicate all that code in the subclass. So what we really want to do is in the subclass's constructor, we want to be able to call the parent class's constructor, right? Within alarm clock's constructor, instead of saying self.time equal time, what I'd really like to do is call clock's constructor and let it do the initialization that supports all of the clocks. The problem is I can't just call underscore underscore init underscore underscore, because if I did do that with an alarm clock, it would call itself. And I'd actually get into a kind of an infinite recursive loop. A init would be calling a init, and I'd actually get an error. Because what I want to do is not call my own init, I want to call the parent's init class. And it turns out that this is a general feature in object-oriented languages, which is that subclasses sometimes want to be able to call the class in a parent that we overrode, because in this case it's the same method name. Init in alarm clock overrides init in clock. So what we want to do is to be able to call the init in the parent class. And the syntax for doing that is to give the parent class's name, then call the method and pass in self explicitly, and whatever other parameters we want to pass in, which in this case is just time, and that's fine. We have time because that was passed in as a parameter into alarm clock's constructor. We can now delete the setting of the time instance variable, and we should be good to go. Let's try running this, and with any luck, it works just like it had before. So no changes in what the code does, but it's a little bit cleaner. Similarly, let's look at the descriptor string. The base class generates a description of the clock, and then the alarm clock essentially duplicates that. Again, it's a very simple duplication, but suppose clock had a more complex string class, and then we were duplicating that in alarm clock. That would be bad. What we want to be able to do is define the string representation in clock that can get reused in alarm clock. And there's a few ways to do that. One is just to call string directly. So let's call clock dot underscore underscore str and pass in self, because that's all it needs. It only takes a single parameter, and I think that should do it. Let's try running it again, and sure enough, it still works unchanged. That is, the output is unchanged. We improved the code.